You get an answer yet? What is it? -1/11. Okay. And Madison found a solution here. Let us double check. First, it's a rational function, right? At -2. This isn't defined. So at -2, the denominator, what is it? At x is equal to -2. This is 5, -3 times -2. And very good, you're right, -1. It's not 0, right? So this function is defined at -2. Very good. So which law should we use? Oh, thank you. Yeah. We always, negative and negative give us positive. Good catch. I don't know why I got this terrible result. Sorry. Sometimes it happens, right? 11. Good job. Now it's defined at -2. So we can use which law? Quotient law? Very good. This is a quotient. So good job. So we can write it as limit of the numerator when x approaches -2 divided by limit when x approaches -2 of 5 minus 3x. Okay, what should we do next? Yes, sum and difference laws to break them into parts. Very good. So indicate this quotient. If I remember correctly, it's law 5, right? Then break it, then it will be limit of x cubed, x minus, x go to -2. Sorry, it's not a good notation, good writing. X approaches -2 plus, and the constant, it will be, we can do it fast now, right? And the denominator here, it will be limit when x approaches -2 5 minus 3 limit. Good job. So is it clear to everyone? We apply the constant times the function law. Yes. Because so now let us compute this first, and I'll answer you right away. So here, so this is a polynomial, right? So we can use direct substitution. Yesterday we've done that. So what is it? Very good. Thank you. -2 cubed gives us -8, and here 2 times -2 squared. Good job. And here limit of a constant will be, itself. Very good. And here, good job. And times -2, right? You should write this way, dot, parenthesis, -2. Very good. And it is 8 -8, right? Plus, and here is 11, right? -1/11. Good job. Thank you, Madison. Great job. Everybody, do you have the same answer? Good. So in this case, we can do direct substitution, right? Is it always true? Can we always substitute this? We don't know. Let's see the next example. Good job. So in this case, we're lucky. It is defined at -2, right? And the rational function is continuous on its domain. And it is defined at -2. In this case, we can use direct substitution. Let us consider another example. Example 2. Okay, compute the limit of x² - 1 divided by x - 1 when x approaches 1. Great, great observation. Thank you. Your name is Connor. Thank you, Connor. Great. So remember, at x is 1, then x - 1 is equal to 0. Then x² - 1 divided by x - 1 is undefined. Therefore, we cannot use direct substitution. Okay, be careful. But if you cannot do that, how can we solve it? Okay, do something now and factor it out. Derivative, we're not studying that yet. Thank you. You know a lot. So now, okay, let us try to simplify it, whether we can solve it, right? Since we cannot use direct substitution and we cannot use quotient law right here, right? Because the denominator is 0 and this is undefined, we cannot use quotient law yet. So x² - 1. So how can we do that? Very good. Wow. Okay, 1 is 1 square, right? And remember, so how does the numerator become? Yes, thank you. And the denominator? Great. So, what should we do? Yes, the numerator and the denominator, we just eliminate the common factor. And this guy becomes limit when x approaches 1 of. Good job. Right. Now, we can use direct substitution, right? So it will be, yes, 1 plus 1 is equal to 2. Great. Well done. So now, do you all get the same result? Very good. So here, the reference I gave you in the Moodles, you can go to the notes reference, download it. And we use this formula. These formulas are very important, very important. You can do it faster, okay? Review it, very good. Now, let us do another example. How about this guy? Compute the limit of this function. Limit of 3 plus h squared minus 9 divided by h when h approaches 0. What do you think? First, how is the denominator? 0. So be careful, right? So this function is undefined at 0. So we need to somehow eliminate this space. How about so how can we do that? Before doing that, observe this. This is something square minus 9, and 9, can we write 9 in different way? Yes, 3 square. Beautiful. So here 3 plus h square minus 3 over h, right? Good. Square, my bad. Okay. Now we can use this formula, right? X squared minus y squared. Something square subtract something else square, it will be what is it? Yes, 3 plus h minus 3 times 3 plus h. Let me write it this way, plus 3. Be careful. Okay, are you comfortable with it now? And the denominator, we just write it again, right? So, are we good? We just apply the formula. Do you have any questions? Okay. Now, can we simplify it? How? Three plus h. In front of that is there's no negative sign. It means that we can remove the parentheses here, right? It is 3 plus h minus 3, and then times 3 plus h plus 3. Make it simpler. So the first parenthesis, what do you think? Yeah, this guy cancel with this guy, right? And therefore, how does it become? Very good. And times Yes, we can sum them up. H plus 6 divided by H here. So now, what should we do? Yeah, I have the same common factor here. We can eliminate it. Cancel. Okay? It becomes now it's easy, right? Will be? Yeah, 0 plus 6, and it will be 6. So, do you have any question? Oh, so the which law is a very good one. Before that, we just do some algebra, right? Actually, in the test, you don't have to write which law you use specifically. I write it here to make sure that you know which one you use for sure at the beginning. But when we get used to it, it becomes natural and easy. So we don't have to indicate it in the test, but make sure that you understand correctly. But these guys, from this manipulation, is simply some algebra. And at the end here, we use direct substitution, right? Or which law you can double check the notes, okay? Yes. Yes, so in the test, you have to write the steps, make sure that you understand and get the result. You have partial credit for throughout this, but you don't have to write it details like this because I try to show you step by step in case, but you can do it quicker. From here, you can jump directly to this step. I will be fine because it becomes easy when we practice, right? Yes. It works. So another way, very good question. You can do another way. You don't have to use this formula to factor it this way. But one way you can do is to expand this guy first, right? And then you can do differently. You expand it. What do you get here? Let's just write another way, okay? Limit when h approaches 0 of 3 plus h square minus 9 over h. You can definitely write expand it. And what do you get? Wow, so fast. Again, please. Huh? Very good. And 6. I want to just use the formula here so that, okay? X squared plus 2 times xy plus y squared, and then h squared minus 9. Good job. Right? Then here 3 squared cancel with 9. Right? Then it becomes but you did fast. Very good. I'm so glad that you do it very fast and accurate. It is 6h plus h squared. H squared, you can think about h times h, right? And then what should we do? Yeah, they share the common factor here. So we can factor it out. So if we factor h out, what do we have inside the parentheses here? Very good. 6 plus 8 plus h. And then cancel it. And finally, you get the same thing. Very good. Okay. Are we good now? People on Zoom? Is it all clear? Good. Thank you. Now, let us do another example. This one is a little bit trickier. Okay. Limit of square root of t squared plus 9 minus 3 divided by t squared when t approaches 0. Okay. Now, pick a piece of paper and write your own guess. 30 seconds starts. What is the difficulty here? Yes, anything else? The bottom is 0. Good observation. What else? What is the difficult thing? This horrible sign, right? We hate it. So how can we get rid of this? Yeah, we can somehow get rid of this. Which formula should we use here to get rid of this? If we can somehow square it, it will disappear, right? Sorry, I should. So look at these. Which one should we use to get rid of this guy? Which formula? If we can somehow square it, it will be perfect. So the closer, I think this one will be helpful, right? Look at this. So any of you has a suggestion? I don't know what to do with this guy. It's so difficult. Help me. Yes, it's a good strategy. Look at this. This guy is something minus something. If we multiply it with what? With this guy plus something, right? Then we can use this formula. We do it in the reverse way. Is that okay? Good. Good job. So we somehow multiply with this guy. That's a different thing, right? We multiply with this. We have 2 divided by the same thing. Good job. Thank you, Sonny. So we should divide it by the same thing. It doesn't change anything. Right? Because we multiply with that and divide it by itself. Fine. Nothing's changed yet. But now we can use the formula. And what do we get here? In the numerator, the first square subtract the second guy square, right? What is the first guy? That one, right? And what is the second guy? This guy. Square, subtract 3 square. Do you agree? So, is it okay now? Are we good? Then the first guy, what does it become? Yes. Something square and then take the square root, then square, it will be the integrand here, t squared plus 9. Subtract here, 3 squared becomes 9, and t squared plus 3. Okay? So, what should we do now? Yes, simplify the numerator. Thank you so much. This guy cancel with this guy, right? Before doing that, let me just write down to make sure that you won't make a mistake here in the future. Since limit t approaches 0, so this guy in front of that, there's no sign, or is this equivalent to having a positive sign here. So we can get rid of the parentheses without anything changed. But if in front of this is a negative sign, you should be careful. Okay? Good. Then subtract 9 and the denominator. Now, these two guys cancel. What should we do now? Very good. T squared, they cancel, and finally it would be, yes, 1 divided by t squared plus 9 plus 3. At t is equal to 0, what does it become? Yes. So the denominator is different from 0. We can substitute it directly. It will be 1 divided by 0 squared plus 9, and then plus 3 here, and finally it will be 1 over 6. Oops, what happened? So are we good? Good job. Thank you so much. You have a good one. Sure.
This one, what did 3 squared come from?